Happy New Year, everyone. This is Gerald McKeegan. I'm up here at the Chabot Space and Science Center in Oakland, California. And it is the first day of the Lunar New Year. So Happy New Year to everybody. Last night was the full moon, or I'm sorry, the new moon. So today is the beginning of the Lunar New Year. And I'm sure a lot of you folks are celebrating in some way. And I'm glad that some of you decided to celebrate by joining us here tonight. I'm up here at the Chabot Space and Science Center. I'm sitting in front of one of our exhibits here. This is our newly refurbished Mercury Capsule. This was the first manned spacecraft or human spacecraft launched by the United States. Dates back to the early 1960s. We've had this full-scale model of the Mercury capsule here at Chabot for, gosh, almost 20 years now. And we've taken advantage of the fact that we are closed because of the pandemic to do some refurbishing. And this has been one of our projects here, is to refurbish the interior of the Mercury capsule. Later on this year, when we open Chabot back for the public, you can come up and you can actually sit inside the capsule and get a sense of what it was like to be one of those Mercury astronauts back in the 1960s as they were orbiting around the Earth or doing suborbital flights. You'll notice when you do that, it was very much an analog era rather than a digital era. So there are lots of switches and knobs inside. It's kind of fun to play with. But of course, over 20 years, it gets its certain amount of wear and tear on it. So Jim Gordon, one of our technicians up here at Chabot, has been working to refurbish it, and it's now looking pretty good inside. So I'm looking forward to seeing when Chabot opens, to seeing some youngsters get inside there and enjoying the experience. So tonight we are going to talk a little bit about what's up in the night sky this month, February. And we're going to start out with a video put together by Don Saito. Don is a Chabot volunteer. He has been with Chabot more than 20 years. And he is an amateur astronomer. He's very much into astronomy and learning the night sky. He likes to use a certain technique for learning the night sky, and you're going to see that during this video. So without further ado, I'm going to start the video. After the video, we'll talk a little bit about what's going on in the video, what's up in the night sky. I'm going to highlight one of the constellations that Don is going to mention. And of course, if you have questions or comments, please feel free to put those in Facebook or YouTube, whichever you're watching. Also, I want to remind you, because we are still working up here at Chabot, we are refurbishing the place and so on, we do continue to need your support. So we would appreciate it if you would take a moment to make a donation to Chabot. If you're on the Facebook page, there is a donate button above the comment section. You can also go to the Chabot website, which is chabotspace.org. And you'll see a donate button at the top of the web page there. And if you can take a minute to help us out, we would certainly appreciate it. So with that, let's see if we can watch a video here. Stand by while we get it set up here. All right, I think we got it ready. Here we go.
Greetings, fellow Earthlings. As you know, the COVID-19 pandemic continues to plague us, so we still can't meet inside our amazing Zeiss Planetarium at the Chabot Space and Science Center. However, we can still use Nature's Planetarium, also known as the real sky, to dress up warmly, step outside, tilt our heads back, and see at least some of the amazing things I'll be pointing out for you tonight. I'm of course talking about the constellations. There are people, animals, and objects up in the night sky. They've been there for millennia, but most people are unaware of them as they glide by unnoticed right over our heads every clear night. Tonight, we will amend this sad state of affairs and put you, the audience, on your first steps toward astronomical enlightenment. As you probably already know, The Earth has 4 seasons: spring, summer, fall, and winter. Well, the constellations also have seasons, having to do with the Earth's yearly orbital path around the Sun. That, and the fact that we can only see stars by looking away from the Sun at night, which changes our view of the stars throughout the year. Unfortunately, unless you're at a good dark sky site, and if the moon isn't too bright, most constellations will be somewhat hard to see fully. But most constellations have at least a few bright stars to help identify them, and the better your viewing location, the more you'll be able to see. A good first step to finding the constellations is done by knowing your compass directions. We can easily do this without a compass using a constellation that is quite easy to see, Cassiopeia, the Queen, also known as the Big W. Face the sky roughly 45 degrees to the right of where the sun had set, and look about halfway up to the top of the sky, and you'll see it. As you can see, Cassiopeia has 5 stars that make up the W shape, which is actually her throne. From this angle, it's kind of face down. This 6th star makes up the seat of the throne, which can be seen to have a rather unergonomic back. Off the tip of the more squashed end of the W, you might see another somewhat faint 7th star. Just connect the end of the W to that star and extend the line about 2.5 times until it comes to the semi-bright star, which is named Polaris and is otherwise known as the North Star. As previously mentioned, the Earth's orbit around the Sun causes our earthbound view of the stars to slowly change throughout the year. The bad news is, Cassiopeia is now heading down toward the northeast, and by April will eventually get too close to the horizon for it to be useful as a pole-finding constellation. The good news is, rising in the northeast is the Big Dipper, a better and easier pole-finding star grouping that will be good to use from now until September. Now, Polaris is the only star in the entire sky that stays pretty much right where it is, so no matter what time of the night it is, or even what month of the year it is, all you need to do is face it, and you'll always be facing due north, with east directly to your right, west directly to your left, and south directly behind you. All the other stars wheel around this pivot point anti-clockwise, making them appear to rise in the east and set in the west. This is, of course, an illusion caused by the Earth's rotation, which gives the appearance that the stars are moving, when in fact it is the Earth that's spinning. If you think of the Earth as a spinning top, and you extend Earth's north polar axis straight up into the sky, it points almost directly at Polaris. Using Polaris, we found all the compass directions, but Polaris is also the end of the Little Dipper's handle, whose official name is Ursa Minor, the Little Bear, and our next constellation. It's a bit faint, but from Polaris, you might be able to trace its curving handle to its bowl. The 2 brighter stars at the end of its bowl are called the Guardians, because they seem to march around the North Star like protective sentries throughout the night. To continue, let's turn our view to the south, like so. This will flip everything we've seen so far upside down, and will enable us to find the rest of the night's major constellations more easily. Right near the very top of the sky, we find Auriga the Charioteer. He's easy to spot because of his bright eye star Capella. It's just his head in profile, but he's got a triangular hat, a hooked nose, his bright eye Capella, and the rest of his large head with big manly chin. To the right of Auriga, we have Perseus, the hero. He's got a tall, thin triangular hat, a head, body, legs and feet. His right arm is curled up behind him, while his left arm is reaching out for his maiden fair, Andromeda. Andromeda is known as the Chained Lady. She got into a bit of a scrape and was chained to the rock so a sea monster could come and eat her, which is why Perseus is so intent on saving her. She's just to the right of Perseus and has 1 star as her head, a torso, and 1 arm pointing out away from her body with a couple of chains attached. The other foreshortened arm is curled down below, and she has 1 straight leg while the other leg is up and bent at the knee. If your sky is dark enough, you might see a dim fuzzy spot just off her knee. Binoculars would make it plain to see even in somewhat light-polluted skies. That's the Andromeda Galaxy, our nearest neighboring spiral galaxy, at about 2.5 million light-years from us, which makes it the furthest object that can be seen with the naked eye. It's on a collision course with our own Milky Way galaxy, but worry not. The collision won't happen for another 5 billion years, give or take a few 100 million. Arcing relatively high above the southern horizon is a kind of invisible line where the zodiacal constellations can be found. This line is called the ecliptic, and is also where the sun, moon, and planets move along. This is why the zodiacal constellations were so significant to astrologers. Not that astronomy scientists believe in the pseudoscience of astrology, most don't. But astrologers were some of history's first astronomers, and for their early work, we are in their debt. Our first zodiacal constellation, located toward the west end of the ecliptic, is Aries the Ram. He's also somewhat faint, but as you can see, he has a small triangular head, body, cute little tail, and outstretched front and rear legs as though he was running around in the starry fields. Located just by Aries' rear foot, you'll notice a somewhat bright reddish star, which isn't a star at all, but the planet Mars. If you ever get a chance to see it through a telescope, do it. Sometimes, if the seeing conditions are good, you can actually see some of its dark surface markings and/or its polar ice cap. Speaking of Mars, 6 days from today, on Thursday, February 18th, NASA will live stream robotic probe Perseverance landing on Mars. Join the team at Chabot, who will carry the feed and have live commentators on hand. Heading eastward from Aries on our line of zodiacal constellations is Taurus the Bull. He's got a big, somewhat triangularly shaped head, 2 horns, front and back legs, a body, and a tail. Take a look at the tip of his right-hand horn, and you'll notice it's not a single star, but a small cluster of stars that kind of resembles the Little Dipper. That is the open star cluster called M45, or more commonly, the Pleiades. The Japanese call it Subaru, and if you look at the medallion on the front of every Subaru vehicle, it shows those stars. Use binoculars to look at it. It's actually quite beautiful. To the left of Taurus, we find Gemini the Twins. This constellation is one of the easier ones to see, as it is composed of 2 very bright stars, along with the rest of the stars that make up their arms, bodies, and legs. Continuing eastward along the ecliptic from Gemini, we find, or rather don't find, the zodiacal constellation Cancer the Crab. I'm being a bit wishy-washy about this constellation because it is quite faint, and unless you're at a fairly good dark sky site with no moon, you'll never find it. As you can see from the illustration, it's a very simple constellation made up of a kind of squashed rectangle with a couple of sticks coming off the top, which are meant to be the crab's arms. Not too impressive. But this constellation does contain a beautiful deep sky object that is easily found with just a pair of binoculars, which I'll describe how to find in a moment. But before that, we come to our last zodiacal constellation of the night, Leo the Lion. Now, I won't describe Leo because he's not quite fully risen in the east, but I had to mention him in order to describe how to find that deep sky object in Cancer. Leo's brightest star is called Regulus, which is the 22nd brightest star in the sky, and we will use it to find Messier object number 44, usually referred to as M44, and also known as the Beehive star cluster. To find the Beehive, draw an imaginary line from Regulus to the closer twin's head, Pollux. Just a bit past and below the center of that line, you'll find it. It's in the upper right part of Cancer's head. Check it out if you get a chance. It's actually quite pretty. Leaving the ecliptic, I've saved the best for last, Orion the Hunter. This constellation is composed of the most bright stars of all the other constellations from both the Earth's northern and southern hemispheres, and is known by most people in the world. He's got a little tiny head, broad shoulders. He's holding aloft a somewhat faint club in one hand, while his other holds forth a shield. Then there's his famous belt of 3 stars, a sword hanging from his belt, and his legs and feet. If you look closely at his sword of quote-unquote stars, you'll notice that the middle star looks a bit fuzzy. Take another look with a pair of binoculars, and you'll see it's not a star, but a fuzzy little smudge. A look with a telescope will reveal a cloud with striations and details. This is the Great Nebula in Orion, a place where new stars are being born, a sort of stellar nursery, if you will, and, as you can see, quite beautiful. Just below Orion's feet is one of my favorite constellations, Lipus, the bunny rabbit. He's got a head, a pair of ears, and a cute little bunny body. Our last two constellations for the night are Orion's dogs, Ursa Major, the big dog, and Ursa Minor, the little dog, which I figure must be a wiener dog because it's just two stars, though one of the stars is Procyon, the ninth brightest star in the sky. Not to be outdone, Ursa Major has the brightest star in the entire night sky, Sirius, the dog star. The ancient Egyptians used to use the first sight of this star as a notice for the annual flood of the Nile River and for when to plant crops. And that's it. There are other smaller or fainter constellations out there, which I encourage you to look for using a good book and maybe a pair of binoculars too. Speaking of good books, I cannot more highly recommend the book The Stars, A New Way to See Them by the author H.A. Rey, who you may know as the same author who wrote the Curious George books. Rey was a scientist who wasn't satisfied with the way modern star charts were drawn. The astroscientists were not interested in the characters, objects, or stories behind the constellations, so for convenience, they just connected the brighter stars into weird geometric shapes, slapped on their Greek names, many of which would mean nothing to the common person, and left it at that. That's all fine and well for them, but for us regular folk, we're more interested in the fun stuff. If you really want to learn the constellations, get Rey's book, which can be purchased from Amazon.com for about $12. I'd also recommend getting a pair of binoculars before getting a telescope. Binoculars are cheaper and easier to use, and there are many wonderful deep sky objects that can actually be best seen with just a pair of binoculars that are noted in Rey's book. If you do want to get a telescope, ask us or research on the web how to make an informed purchase. Be warned, there are a lot of bad telescopes out there with cheap components and shaky, muddy, fuzzy views that will disappoint you every time. A good scope will inspire you and your children to a lifetime of deep space exploration and an appreciation of science and nature in general. If you're interested in getting into the hobby of astronomy, joining a local astronomy club can be most helpful. Chabot is partnered with the EAS, the East Bay Astronomical Society, which has many activities and resources you'll find essential to help you get started in this amazing and beautiful study of our natural universe. Thanks for watching this video. If you like this content, be sure to click the thumbs up button, subscribe to our channel, and hit the bell notification icon to find out when new content has been uploaded. This will really help our channel to grow, which would make us all very happy. And until we meet again, we'll see you in the future!
All right. Well, I hope everybody enjoyed that. Covers an awful lot of material there. So if you feel a little overwhelmed, I'm going to just focus on one of those constellations tonight. And maybe when the weather is clear, you can go outside and just check out one of those constellations. We'll cover quite a few constellations over the course of the year because we're going to continue to do this. Even after Chabot opens, we're going to continue doing programs like this. So if you hang in there for just a couple minutes, I'll try to talk a little bit about one of the constellations that Don talked about. Again, I'm up at the Chabot Space and Science Center. I'm sitting in front of the Mercury Capsule. Joining me tonight is Jessica Williams. Jessica is one of the program managers at the Chabot Space and Science Center. She's the one that helps put all these virtual programming together. And she's going to be watching Facebook comments and YouTube. And she's going to be relaying questions to me as we go along here. So if you've got any questions you want to ask while we talk about some of these things, just type them in and Jessica will see them and she will pass them on. All right. So I wanted to share an image with you. Like I said, I'm going to focus on just one constellation tonight and talk a little bit more about it, and also talk a little bit about what our sun would look like if we were very far away. So hopefully you can see this. You see, we're looking at the southern sky here. This is planetarium software that I'm using. And this is a view of the southern sky. So if you went outside tonight, if the sky was clear, turned and faced toward the south, these are some of the stars that you would see. And the thing that you would notice, the easiest thing to spot is this constellation right here, which I think most people recognize is the constellation Orion. Orion has these three stars lined up, very distinctive, easy to see. And as Don mentioned in the video, Orion has more bright stars than any other constellation in the night sky. So it's a really easy constellation to find. And in mid-April, or I'm sorry, mid-February, it's almost straight south around 8:30 at night. So it's a good anchor point to use when you're trying to find other objects in the sky. One of the things that Don mentioned in the video was this star Sirius, the brightest star in our night sky. And if you take the three stars in Orion's belt and you follow them down and to the left, they point right at that bright star Sirius. It's 8.2 light years away, and it is the brightest star in our night sky. Sirius is actually two stars. It's a very bright primary star, and then it has a small star called a white dwarf that orbits around it. Most of the time, that white dwarf is very close to the star, and we can't see them. Even with telescopes, we can't see that there are two stars there. But every once in a while, because of the orientation and shape of its orbit, it gets far enough away from Sirius A, the primary one, that we can actually pick it out. And we're right at that time. So if you join us over the next couple of weeks for our virtual telescope programming on Saturday night, there's a good chance that we will point the telescope at Sirius and try to pick out that small white dwarf that's orbiting around the primary star of Sirius. But what I wanted to point out to you is another constellation. I'm kind of just focus on one constellation tonight. So here's the belt of Orion. This is the star Betelgeuse. It's a yellowish orange star that's up and to the left of the belt. And if we go from the belt across Betelgeuse and up to a group of stars right here, this is the constellation Gemini. And I'm going to see if this works here. I'm going to try to zero in. Yeah, there we go. Okay, so here's again the Orion constellation. And here's the belt. Here's Betelgeuse. We follow it up and you see a group of stars right here called Gemini. And Gemini is distinguished by these two stars here, Castor and Pollux. This is Castor, this is Pollux. And they're named after two brothers in Greek mythology. We often call them the twins of Gemini, although technically they aren't twins. They are brothers, but they are not twin brothers. But they are often depicted in the night sky. These are the two bright stars represent the heads of Castor and Pollux, and then their bodies are here, and they're often shown as dancing together in the night sky. So I'll try to zoom in a little bit more here. Here's how you would see things in a star chart. All these lines connecting all the stars together. It gives you a better idea. This is Orion, this is Gemini, and here are some of the other constellations in the night sky. But let's just talk about Gemini for a few minutes. All right. So this is the constellation Gemini. And again, this is Castor and Pollux. And Castor is a very interesting star. To the naked eye, it looks like one star. But when we zoom in on it with a telescope, we discover that it looks in a telescope like three stars. And when we analyze the light coming from Castor, we realize that we're actually seeing six stars. Um, so it's three stars that are so close together that to the naked eye, they look like one star. And we can see all three of them pretty easily with a reasonable telescope. But when we hook an instrument to a telescope called a spectrometer, and analyze the light coming from those three stars, we discover very quickly that there's two sets of spectra, two sets of light waves coming from the stars, and they're moving relative to each other. And that tells us that each of those three stars that we see in the telescope is actually what we call a spectroscopic binary. It's two stars orbiting around each other. So what we see with the naked eye is one star is actually six stars. And this turns out it's very common in the night sky. Probably half the stars that you see with your naked eye, if you go outside at night, half of those stars or more are multiple star systems, at least two stars, often three, four, five, or six stars, so close together, and in many cases orbiting around each other, but they appear as one star to the naked eye. Now, the reason I wanted to focus on Gemini is because there's a question that people often ask me, and that is, when we go outside and we look at the night sky, even in light polluted skies, we can still see a few hundred stars. And when astronomers talk about the stars, we say, well, those stars are dozens of light years away, hundreds of light years away, what have you. And people often wonder, well, what would the sun look like if it was, say, 50 light years away? And the answer is, if you see all these bright stars, the sun would not look like any of those stars. Our sun, in terms of the size range of stars, it's kind of down towards the low end. There are a lot of stars that are twice as big, 10 times as big, even 50 times as big as our sun, and more massive than our sun. There are a lot more stars that are lower mass than our sun, smaller than our sun. So we're not quite, you can't really call us an average star, but we are kind of at the lower end of the possible size range. And because of that, if our star was very far away, if you were looking at it from, say, 50 light years away, it would not appear very bright. In fact, in this image, there is a star which you cannot see with your naked eye. You can only see it maybe if you were in a very dark location, like high up in a mountain, far away from city lights, you might be able to pick it out. But you'd need a pair of binoculars or a telescope to really see it if you're anywhere close to city lights. And the star I want to point out is this one right here. This is the star 37 Geminorum is what it's called. That star is almost a twin of our sun. It's 56 light years away. It's actually slightly brighter than our sun, a little bit more massive than our sun, but almost our twin. And that star is 56 light years away. And you see how faint it would be compared to all the other stars in the constellation Gemini. It turns out that trying to see our sun from a great distance of several dozen light years, it would be hard to pick out in the night sky. So I thought that would be an interesting way to answer that question. What would our sun look like if we were 50 or 60 light years away from it? All right. I think I've got a couple of other images here. Yeah, here's without all the lines. And there we go. There it is, 37 Geminorum. And it's, like I say, it's 56 light years away. You can see over here in the text description here, 56.9, I guess it is, light years away, and very hard to see, almost impossible to see with the naked eye. You need a telescope, binoculars or a telescope to see it. All right. So I just thought I'd share that with you. If you get a chance, go outside, see if you can find the Gemini constellation. Again, go from the belt of Orion up across Betelgeuse, and that'll lead you right up to the constellation Gemini. And if you've got a pair of binoculars, look and see if you can find 37 Geminorum and get an idea what our sun would look like from a great distance. All right. Okay, Jessica, how we doing on questions?
Hey, Gerald.
Hey there.
Yeah, we have a couple of questions.
Okay.
So the first one says, in the video, Dawn states that Orion's dogs are Ursa Major and Ursa Minor. Isn't it Canis Major and Canis Minor?
Did he say that? You are correct. It is Canis Major and Canis Minor. I'm gonna have to go back and rewatch that video. and if you're right, I'm gonna jump all over Dawn about that. But yes, you are correct. Orion's dogs are Canis Major and Canis Minor. There is a Ursa Major and Ursa Minor, but it's on the opposite side of the sky. It's in the northern sky, whereas Canis Major and Canis Minor are in the southern sky. So yes, you are correct. Canis Major and Canis Minor. And Sirius, the bright star, that is in the constellation Canis Major. And then he mentioned Procyon, that's in Canis Minor. All right. Other questions?
All right. Any particular brand of binocular that you recommend purchasing for my 10-year-old?
Gosh, I'm not sure I'd want to recommend brands. I have a pair of Bushnell binoculars that I'm really fond of. I like the feel of them. I like the weight and so on. But there are a number of different companies making binoculars. Celestron makes binoculars, Bushnell. Gosh, I don't know who all else makes binoculars. The thing I would recommend is that you get a pair of binoculars that has the front lenses are either, say, between 40 and 50 millimeters in diameter, and the magnification is between 7, 8, maybe 10, no more than that. And the way you find that out is when you look at the description of the binoculars, you'll see two numbers. For example, my Bushnell binoculars, the numbers are 8 by 42, so 8x 42. And the 8 represents the magnification of the binoculars, and 42 is the size of the front aperture. If you get a pair of binoculars with bigger aperture, like say 60 millimeters or something like that, they tend to be heavy. And if you get too much magnification, like 12 or 20 or something like that, you get too narrow a field of view, and it's not very enjoyable. So to get a pair of binoculars that are comfortable to use and yet give you a good view of the night sky, I would stick with, say, 40 to 50 millimeter front aperture, and somewhere between 7 and 10x on the magnification. And then what you want to look for is just something that you feel comfortable with, that is easy to use, easy to hold up. There is a feature on many good quality binoculars that you want to look for. Most of them have it. Most people don't realize they have it in the binoculars that they have. And that is a screw hole that's in the axis, the swivel part of the binoculars, and usually it's on the front end, and often you see a little button that has the company emblem on there, and what you discover is you can unscrew that button, and there's a screw hole there, and it turns out that that screw hole is the same size screw hole as what you see on the bottom of a SLR camera. And you can take and mount your binoculars to a tripod, a camera tripod. You have to get a little L-shaped bracket, which you can buy at a camera shop. And that allows you to mount the binoculars on the tripod, which makes it very easy to look through the binoculars. You don't have to hold them with your hand and worry about shaking the binoculars. You can mount them on the tripod and point it at some object and keep it nice and steady. And I use that all the time. I just grab the binoculars, mount it on the tripod, and when I'm looking at things, that's the way I keep them nice and steady. Because even lightweight binoculars, when you're trying to hold them and look at an object, especially if you're looking for a long period of time, it's kind of rough to have to hold them all the time. You start shaking a little bit. So that's a little accessory that I would recommend if you get a pair of binoculars. And I do recommend getting binoculars before you buy a telescope. All right. I kind of rambled on there, Jessica. Any other questions?
Yes. Okay, so since 37 Gem is similar to our sun, would it be possible to have a galaxy like ours out there?
Well, yes, actually quite a few galaxies similar to ours. The Milky Way galaxy is a little bit on the large size in terms of comparing it to other galaxies. There are larger galaxies. In fact, the Andromeda Galaxy, which is our closest sister galaxy, is actually bigger than the Milky Way galaxy, but there are many other galaxies out there that are similar in size or even a little bit smaller than the Milky Way galaxy. So there are a lot of very similar galaxies. When we are doing the virtual programming on Saturday night with our telescope, we often point at other galaxies, many of which are similar in size. In fact, as we get into springtime is actually galaxy time because of the orientation of the Earth's orbit around the sun. In the springtime, we are able to see the largest number of galaxies in the night sky. So as we come up here, starting in March and April, we're going to be looking at a lot of galaxies with our big telescope during the virtual telescope program on Saturday night. So you want to check that out. But yeah, there are a lot of galaxies out there, very similar to our own. All right. Other questions?
I think that's all for now.
Oh, really? Okay. Well, once again, I want to remind you that next week on Thursday, the Perseverance rover, along with the Ingenuity helicopter, are going to land on Mars. And we are going to be covering the landing starting at noontime on Thursday the 18th. We will cover the landing. We will be simulcasting the NASA TV feed, and we will be providing commentary about the landing and telling you what the events are that it goes through as it goes through the landing process. And taking questions. So if you've got any questions that come up while you're watching that landing, you can type them in and we will answer them for you. There will be a couple of us doing that. And then after the landing, the final touchdown will be right around 12:55. And after the landing, we are going to have a couple of guests, two NASA engineers who worked on the Ingenuity helicopter. They're going to join us for a Q&A session after we cover the landings. So you want to check that out starting at noontime on Thursday, February 18th, noontime Pacific time. If you're somewhere else in the country, you can still join us. Just make sure you join us at noontime Pacific time, and we'll cover that event. And then, of course, we're going to have our virtual telescope every Saturday night, starting at 9 o'clock Weather permitting, we will put a camera on our big telescope and point it at different objects of the night sky and tell you all about them and answer your questions about them. So, great opportunity to learn a little bit more. And who knows, maybe in the next week or two, if the weather cooperates, we'll even point that telescope at 37 Geminorum and let you see what the sun would look like in a telescope from 56 light years away. All right. So I want to thank you all again for joining us. I want to encourage you to click on that donate button or go to the Chabot Space and Science Center webpage, chabotspace.org. Click on the donate button and continue to support us. We will be reopening our facility later on this year. So you want to watch for that. It'll be publicized on our Facebook and YouTube pages as well as on our website. So we're all got our fingers crossed that the pandemic goes away eventually here. We'll be able to open the museum and invite you back up and let you see all the new exhibits that we're going to have and meet some of the people that you've been watching on virtual programming. So join us then. All right. Everybody have a good evening, and we will see you maybe tomorrow night for our virtual telescope.